Hello, I'm Mehrdad Simkhani, your calculus professor, and this lesson is about L'Hopital's rule. But first, before we get to L'Hopital's rule, let's talk about some indeterminate forms. There are more than these two, but these are the two where we can apply L'Hopital's rule. 0 over 0 and infinity over infinity. They appear in limits. These are some simple examples. Limit of x over x as x tends to 0. This is 0 over 0 type because that x tends to 0. This x tends to 0. Now we have 0 over 0. The same for 5x over x. 5x tends to 0 as x tends to 0. X tends to 0, so you get 0 over 0 again. And x squared over x also is of 0 over 0 type. Because as x goes to 0, x squared would also go to 0. The square of the number also gets closer and closer to 0. So here's x over x squared. That too is 0 over 0 type, which is the same as the one above, the same functions. So here, sine x over x as x tends to 0. Sine x goes to 0 as x goes to 0. X goes to 0, so this is 0 over 0. And how do we know sine x goes to 0? Here's the unit circle. We know the y-axis is the sine axis, and 0 is here on the unit circle. This is 0. So whether from higher numbers x goes to 0 or from the lower numbers, the sign would be 0. And then similarly, sine 2x over x is also of type 0 over 0. Tangent of 5x over x is also, as x goes to 0, tangent goes to 0. Tangent of 0 is 0. Because tangent is sine over cosine. Sine 0 is 0, cosine 0 is 1, 0 over 1 is 0. X goes to 0, so this is 0 over 0. Here we have the log function. Here's the graph of the log function. And it has an x-intercept 1. So ln of 1 is 0. Now here, as x tends to 0, the numerator tends to ln of 1, which is 0, and denominator tends to 0. That gives you 0 over 0 type. Ln of x over x, as x goes to infinity, you can see from the graph, it's an increasing graph without bound. It keeps getting higher and higher, the ln, but slowly. Doesn't matter whether it goes slowly to infinity or at a higher rate. You would know that ln of x tends to infinity. As far as the type is concerned, it doesn't matter, the rate doesn't matter, but to get the actual answer, the rates do matter. We will see. It's still infinity over infinity, and one of those two types, 0 over 0 and infinity over infinity. These are the two types we apply L'Hopital's rule to. There are other types of limits which we consider in this lesson, and we reduce them to these two types. Here we have x tends to 0 from the right. This means from the right. So x tends to 0 from the right. On the x-axis, here's the origin, x is on that side, on the plus side, and it's tending to 0. That's what that notation means. X tends to 0 with a superscript, and that means from the right. If it was from the left, we would use a minus sign. The reason you want this from the right is because the ln function right here is only defined for positive x's, so x has to go from the right. So here's the graph of the ln of x, and x tends to 0 from the right, then ln will go down to negative infinity. So the denominator, this tends to negative infinity. In the numerator, 1 over x tends to positive infinity, because as you make x smaller in the denominator, like 0.000001, 1 divided by that would be a very big number. So this keeps getting bigger as you make x smaller. And this is considered infinity over infinity. Regardless of the sign, we don't care about the sign. In getting the actual final answer of the limit, it does matter, obviously. With the plus or minus, you get two different numbers as a limit. But as far as knowing the type of the indeterminate form, this is still considered infinity over infinity type. So again, we are concentrating on 0 over 0 type and infinity over infinity type, and apply L'Hopital's rule to these two types. And that's the only two types of limits L'Hopital's rule directly applies to. You will see in this lesson, in the subsequent videos, that there are other types we're going to consider, but we will reduce them to these two special types, so we can apply L'Hopital's rule. Here, as x goes to infinity, again, just like above, ln goes to positive infinity. From the graph, it's clear. As x goes to positive infinity, ln goes to positive infinity. The same for a square root function. As x tends to infinity, square root of x also tends to infinity. So this is again infinity over infinity type, just like the previous two types, the previous two examples. This is my last example. Here, as x goes to 0, cosine goes to 1. Again, the unit circle. This is the cosine axis, and this is the sine axis, and here's the 0. Now x tends to 0. It goes either from above or from below. Then the cosine of it, which moves here, tends to 1. So this tends to 1 minus 1, which is 0. X tends to 0, so this is 0 over 0 type. In the next video, we look at the actual L'Hopital's rule and apply it to these limits. So we will see these examples again, and how we apply L'Hopital's rule to find their actual limits. For the first couple, they're simple limits, but we are still going to apply L'Hopital's rule to all of these. And see the next video.